Good afternoon and welcome to Tulane University. It is my pleasure to introduce our next session, Data-Driven, the role of AI and analytics in the future of energy. If time allows, at the end of the session, the panel will take questions submitted by the audience. And to submit a question, please scan the QR code located on the screens around the room. Please be sure to silence your cell phones. Enjoy the conversation, and please join me in giving a warm welcome to our moderator, Provost Robin Forman of Tulane University.
Thank you. Yeah, thank you all for joining us for what I think is going to be a really fascinating conversation. We all got to meet each other outside, and you missed already a fascinating conversation on this topic. So now's our chance to include you in the work. So let's start by having the speakers, the panelists, introduce themselves. Why don't we start, Fariba? Why don't we start with you? It's Fariba Mamaghani, Assistant Professor, A.B. Freeman School of Business. Why don't you just say a little bit about the journey that brought you to be with us today?
Thank you.
Move your mic in front of you.
Okay, I think right now is good, yes. Hi, my name is Fariba. I'm Assistant Professor of Management Science. I got my bachelor and master degree in industrial engineering from Sharif University around 12 years ago, and I worked for a few years as a product and marketing manager. Then I moved to United States. I joined UT Dallas, and I got my PhD in operation management. 7 years ago, I got interested to do research in energy market, and then from that point, my career and my journey changed. And then in the last 7 years, I focused on the energy market, specifically residential sectors. I'm using game theory, mathematical tools, optimization to solve some complex problems and challenge in the energy market. Some of the works that I've done is about just solving the dust spiral problem, offering the efficient microgrid system design, and then finding some optimal pricing decision for when we have customers in the market that their decision is not very rational. And in the last year, when I saw the AI is just booming, I started to just working with data. And then right now I'm working with data, trying to combine the data to find solution to have a sustainable future. And also here I'm teaching statistics to our energy students, MBA and PMBA students as well.
Great, thank you. And okay. Next, we have Hridesh Rajan, Dean of the Tulane School of Science and Engineering.
Thank you, Robin. It's such a pleasure to be here. Thank you for this, our great forum. This is my name is Hridesh Rajan. I am a brand new Dean of the School of Science and Engineering. I've been here about 4 months. Prior to this, I was at Iowa State University, where I was Professor of Computer Science and the Chair of the department. My PhD is from the University of Virginia, where I've spent a number of years thinking about design and issues related to modularity in design. For the last 7-8 years or so, I have been thinking about how to build AI models more sustainably. In particular, one of the problems that my research group looks very carefully at is, can we reuse pieces of built AI models to create new models, so you don't have to spend as much energy building these very large models. This is an interesting forum, and I come at it from the viewpoint of AI for energy and energy for AI. I think that you're going to be hearing me talk about this duality later on in the day. Thank you.
Yeah, thank you. And every panel needs one ringer. And so I'm really pleased to introduce our ringer, Andy Quick, who's Chief AI Officer at Entergy.
Yeah, thank you. Now I feel pressure being the ringer. Yeah, Andy Quick, Chief AI Officer at
You often need to bring your microphones closer to your mouth.
How's this? How am I doing? Good? A little better? I'm practically eating this thing. All right. Is that good? I'll make sure I don't poke my eye out. Good. Yeah, Andy Quick, Chief AI Officer at Entergy. I've been with Entergy for over 28 years in a lot of different variety of roles in technology and innovation across the years. Before that, I was in consulting. Currently responsible for driving AI at scale at the company. So trying to find ways to use AI to create value for all of our stakeholders, our customers, our communities, our owners, and our employees as well. Let's see, what else? Went to Tulane, graduated MBA 2001. I've also been an adjunct instructor at the university as well, so I have that personal connection. Happy to be here.
Yeah, thank you. So what's interesting about the panel is we have three people who are approaching the subject from three different perspectives. From the computer science perspective, then from the business perspective, and then as an industry insider, thinking about how it's going to change the industry largely from the inside out. So let's start with the major question. We're here to talk about the future of the energy industry. So where in the energy industry do you think that the emerging AI technology will have the most impact? I'm asking you to look into your crystal balls and think into the future. What's going to change as a result of the emerging access to AI technology? I don't know who wants to go first.
I think
Okay, I'm
maybe
getting
I
a
should
lot of
take-
looks over here,
Yeah.
so I guess I'll go first.
Yeah.
I mean, I think it's going to be applicable across the entire really value chain, from generation, transmission, distribution, all the way to the retail facing, and also the corporate function as well. And I think the big opportunity is around operational efficiency, without getting into very, very specific. So whether it's work that happens in power stations, whether it's work that happens in the field, whether it's work that happens in the contact center, whether it's work that's happening in the corporate office, there's dramatic, radical efficiency improvements that can be attained if artificial intelligence is used in an appropriate way. So that's kind of a broad answer, but as I think about how things are going to change, I think the key word is efficiency.
Yeah, great. Fariba?
Okay, I can answer this question from academic side, academic perspective. Actually, for many, many years, I think most of the researchers in the academia, they were trying to solve one question in the energy market. It was about the matching supply and demand. Right now, the AI is a promising solution for this key challenge, because when we are talking about the matching supply and demand, one thing that makes it really hard to solve is that there are so many things going, so many factors that are impacting both demand and supply, and because both of them, they are fluctuating constantly. For example, consider the weather. Weather change. When weather change, our consumption will change. When weather change, our supply will change as well. Specifically, right now, we are expanding more and more renewable energy in the market. Then when we see that both supply and demand, they are fluctuating because of the weather, it's really hard to manage and to balance them. But right now, the AI would be a very helpful solution here. AI would be very helpful and very, I think, promising tool to predict the weather patterns, to predict the demand with more accuracy, at the same time predict the supply from renewable sources. And I think from this side, the AI would be a promising solution for matching supply and demand, and this should be very good news for academic people. They were doing research for many years, and they were trying to find a demand response program to regulate the demand.
Great, thank you.
So I will approach the duality again: AI for energy, energy for AI. Right? I mean, so let's talk about AI for energy for a little bit. Precision is going to play a very large role. What do I mean by that? So take an example of transmission line. A transmission line is currently over-provisioned usually. So you can send a certain amount of electricity through a transmission line, and that's usually assuming the worst possible weather, so highest temperature that you can have in that area. But that's not always the case. So one could utilize AI to, for example, push a larger amount of electricity through the transmission line compared to in colder weather than in hotter weather. And these kinds of adjustments that were previously not feasible will now become feasible because of AI integration. Other area where I see a lot of potential is thinking at a systemic level. So AI is in our homes, AI is at our industry, AI is at places that generate electricity. Now each of these pieces are operating independently. So there is a significant opportunity there to combine these pieces to take a systemic perspective and do a system level optimization that is beyond human beings, but might be possible using AI. So that's a great opportunity that I see. So turning the table a little bit and thinking about energy for AI. By last measurements, 3% of energy produced today is consumed by AI, and it's expected to become 5 to 7% very, very soon. That's a major demand that AI systems are placing upon our energy system. Now, there's a rest of the 97% of energy consumers also, but 3% is a major chunk. So thinking about that, I think there are opportunities there, and we will see innovations in how more value could be derived out of this. Someone a couple of days ago was joking with me and saying, human beings tend to invent functions that take energy and convert that into value. And AI has been one of the most efficient such functions. And then I joke with them, are you talking about cat videos here, which are also used? But in general, joke aside, AI is going to be one of the functions that will convert energy into values in one of the most efficient ways that we have seen so far.
Yeah, so let me follow up on that. We've been talking a little bit about use of AI in the industry and how we make things more efficient, in some ways behind the scenes. Mm-hmm. What's your pitch to the energy consumer who doesn't know AI and just wants to turn on a light switch or fuel a small company? How are they going to experience this AI revolution?
Well, I think it can be in a variety of ways. I can, some specific examples. I can cite one, a specific one at Entergy. So using AI to help improve the reliability of power, I think that's the number one, right? Keeping the lights on. More folks generally are looking at their bill and their price of electricity, and they're concerned about affordability and reliability of their power. So AI can be used to detect problems with equipment before it fails. And so for a consumer who's wondering, how is AI going to help me? The short answer is, we're going to use it to help your power be more reliable. Mm-hmm. And we're going to use it from an efficiency perspective to help drive down costs and improve affordability.
Yeah, great.
Actually, to answer this question, I want to refer to one of the actually most important research that has been done with one of the famous professors at Berkeley many years ago. In this empirical research, he was showing that when it comes to electricity consumption, the customers in the market, they are making decisions with limited attention. As a human being, we have a limited cognitive ability to process information. When it comes to electricity consumption, we are busy every day. Maybe we are not paying attention. The weather is changing, what's happening in our house, and then we are just running our AC. We are not changing inside temperature, and then, or maybe we don't care. For example, right now we need to just charge our car. We are charging our car right now. And I think the AI in this area would be very beneficial for our customers, because when AI comes here and then we are able to integrate the smart meters with AI and IT devices, and then we can create a harmonic system. In this case, the AI will make informed decision instead of human for people in the house. Instead of me to think about the electricity bill that I want to pay at the end of month, maybe I'm not thinking right now because I'm busy, I'm writing paper or doing something else. AI will think about me, okay, the outside temperature is going up. I have to change the inside temperature to reduce the bill for this person. Or maybe I can tell that, please just change the inside temperature to make it more comfortable. I'm seeking more comfortable rather than saving money. Or maybe I can just connect all of my devices in the home and just ask the AI to schedule them to, for example, charge or run the different devices during the off-peak time. Because the time that we are using the energy, it matters. And this is the main thing that as a human being, we are showing not rational behavior. We are showing irrational behavior. And I think AI will help us to just cover the gap and schedule and run the devices for us in the time that the electricity is cheaper and affordable and we can save more money.
So before going on to Hridesh, let me ask the two of you a question. So we've heard that AI will help us produce energy more efficiently at a lower cost, and then AI will help us use energy more efficiently, therefore saving money. Mm-hmm. Both of those seem to be in a good direction. So how much lower is my energy bill going to be in 10 years?
I probably need AI to predict that. I'm not really sure. It's hard to say. I'll say that we are working, and there's a lot of different levers to be able to lower electricity, lower cost for sure, and improve reliability, which is also very, very important to our customers.
Yeah.
So, yeah. For example, we can predict when a transformer outside your house is going to fail using AI, and so picture a different experience where instead of if you know where a transformer is outside your house, if it goes bad, your power goes out, you call the utility, you wait, we roll a truck, you get power restored, maybe you're waiting for 5 hours. And now we can, using AI, detect when that transformer might go bad in advance, and then proactively remediate the issue. And so that gives you more reliability, better experience. Mm-hmm.
Yeah. Mm-hmm. So Hridesh, I don't know how the user experience.
So user experience, as my fellow speakers mentioned, that user experience is going to change drastically. I think we'll be more in control of overall optimum conditions while utilizing energy that is lower. And to answer your question, costs may not go down, but costs will not go up in proportion to what they might otherwise. And that is a real economic question that we have, and the power companies are asking these questions as there are pressures on them to increase capacity, increase energy capacity. And it costs a lot. I mean, we don't think about that, right? I mean, it costs a lot to build the transmission capacity. It costs a lot to build the production capacity, to be prepared. And all of these costs have to be incurred many, many years in advance before somebody starts to pay the bill. And sorry, I'm speaking on behalf of Andy here for a little bit. But these costs, with smarter decisions, these costs may or may not be transferred to the customers. Yeah.
So we're talking about the transformation of an enormously large, complicated industry, and so I'm wondering what you all see as the greatest challenges to getting through this disruptive period and getting to the best possible answer. I can imagine challenges of financial sort, technological, cultural, ethical. What are the obstacles you worry about most in terms of getting in the way where you think we can get to?
You want me to go first? You want to
Yeah.
go? There are a lot of challenges, and I think it's a long road. There's no silver bullet. There's no switch to flip to get AI going across a very large company like Entergy, and so it's going to be a long road to fully integrate AI at scale across the board. So there's all kinds of different challenges. One is actually around data, because to really leverage AI and get a lot of value out of it, you have to have high quality curated data to be able to take full advantage of it. And that's one. The other really is, I'll call it sort of adoption. Although there are a lot of folks that are fans of AI and are excited about AI, folks have some trepidation approaching it. So AI is just a tool, and value, whatever the benefit is created, is only going to be had by people using the technology. So some people are excited about it. Others, I come and I say, hey, I'm the AI guy. I'm here to give you something with AI. There's some level of trepidation. And so there's sort of the human change element of it that is another big challenge. So that's probably I'd probably put that one as the biggest one.
Yeah, I'll just comment. Obviously, the energy industry has always been a data-intensive industry forever, and there's always been a value in collecting more and more accurate and more up-to-date information. But AI has added more impetus to that, incentivize that, because now there's a different kind of story about what we could do with that data.
And when you start using AI, what you found, or what we've learned, I should say, because we've only had an AI function since March of this year, so it's fairly newly hatched, is that when you start trying to use AI, it really shines a light on where there is bad data that you may not have known about, and which is good, because then you can do something about it.
Yeah, so the question is, what are the challenges we face in getting to the utopian output where my energy bill has been reduced by half?
Actually, I want to answer this question from completely different perspective. In one aspect, we can see that AI can help us to reduce our bill. We can have AI to schedule electricity, schedule the devices and appliances for us to run the devices when the electricity price is low. But I think there is one main question right now and needs to be answered, that if we cannot answer this question, maybe our electricity bill goes up because of the AI. Right now, we have more than 8,000 data centers in the world, and most of them, they located in the United States. And this data center, as our other panelists, they mentioned, they are using more and more electricity. For example, each prompt or query that you are typing in ChatGPT is using 10 times more energy compared to a Google queries. Or sometimes, as a fun, I'm trying to generate one picture with AI for my class or slides, and then I figured that just generating one picture with AI takes as much as energy as charging your cell phone. And with this much energy that we are using, we are putting pressure on the power grids. We are increasing the demand, and increasing the demand will increase the electricity price. And who pays the electricity bill? Customers mainly. If we couldn't figure out the solution to maybe isolate the data center from the public grid, or we cannot find the different solution for our data centers, finally we have to pass this pressure to our customers. This is the same thing happened when we were expecting and we were expanding the solar panel in the market. 10, 20 years ago, based on the many environmental and the good incentive, we were asking people to install more and more solar panel. And what happened in the area that they increased their solar adoption, we saw the electricity price going for the customers, even for the people that they are not able to install the solar panel. The same thing right now happening for the customers. And right now, maybe if you are reading the news, you'll see that in the areas that the data center they are located, for example, the Virginia, the people they are complaining in the last 2 years, electricity bill is going up for them because the demand is really high. The utility company, they have to increase the electricity price, and the residential customers, they are paying for that. And I think we have to just come up with some solution to make sure that AI helping us to reduce our bill, not increase our bill.
Yeah.
So there are, of course, challenges. The Loudoun County example that you mentioned, it's a real issue. Energy, cost of transmission line upgrades is being passed on to customers in that area. But there is also this interesting dynamics that we're going to see play out. And some years ago, I heard this, and I thought about it for a little bit. Somebody said to me, passing around a bit is much cheaper than passing around a watt. Right? And I thought about it for a little bit. Passing around, what do they really mean? The transmission of information is much cheaper than transmission of energy. That's what they mean. Passing a bit is much cheaper than passing a watt. Now, some years ago, we heard a different thing. Some years ago, we heard that passing a bit was much cheaper than recruiting people to work on that bit, right? And so that led to outsourcing, because people could pass the bit to different parts of the world where work happened in those parts of the world, and then the bit was passed back to where the information was needed. So we're going to see this dynamics play out. We're going to see this dynamics play out in the sense that where the works are cheapest, we will see investments in those localities. And those are very different localities, right? I mean, the needs for data centers does not need a very educated workforce to run. It can run in a sparsely populated area. So 1,000 or 1,500 person town is, with a lot of land around it, water and so on, is a great location for a data center because it has all the ingredients to make to run it. It's a cheap power. So we're going to see all this dynamics come into play in the communities as the world evolves around it, and that's going to be very interesting to watch as to how economics of this changes where power is produced and where power is consumed.
Yeah, thank you. I have a question asked that in some ways it's for me, not for the audience, but you're all experts, you're all immersed in this, you're all in the weeds. And a lot of what we see about artificial intelligence is written for a general audience or communicated to general audience. I'm wondering from your perspective, what questions you're really interested in that may not be common knowledge, that may be a little, inside baseball for each of you. And at some level, what questions are you thinking about that may be new to all of us, but have emerged in your work as a topic of interest?
I would say, for me, it is what we're learning. I would say is how AI is a very broad term. So AI, and not to get overly technical, but when ChatGPT came out in November of 22, that was sort of AI to most of the world, right? And those of us that are more inside the tent, especially in academics, know the full history of it. So we decided at Entergy to broadly define AI to be sort of an umbrella term to include generative AI tools like ChatGPT, but also advanced data analytics, data science, automation, software, big data. So we purposely branded what we call AI as something that's very broad to make the tent really, really big. So the key question in my mind, and this is a little bit more on the techie side of it, is how might we combine all of these together to have sort of a force multiplier on the value? Because every one of those things by themselves has a utility, has a use, has potential value. But I think looking at by itself, looking at a tool like ChatGPT or a Gen AI tool by itself, it's kind of a one-trick pony, right? It's got what it can do. It's very, very niche. But how might you combine that, right? How might you combine that with robotic process automation and advanced data analytics working in concert to solve some really, really gnarly problems? So that's the question that is on my mind probably every day.
Yeah, that's a great answer. Thank you.
Again, I'm trying to answer this question from different perspective. I think one thing that right now in my research papers also I'm working on it, I'm trying to find out what is the best solution for the power of the data centers. There are so many different solutions. One is that integrating the renewable energy with the energy storage. One is that building microgrids close to data centers. Or some tech companies such as Google and Microsoft, they are trying to build their own data center and they are trying to have their own generator and they are trying to provide electricity for themselves. There are so many different solutions right now. But I think the main question is that how much we should invest in renewable energy and where is the best place. For example, right now, the people, they start investing more in Phoenix and Dallas because they are the area that we are expecting to generate more renewable energy. and then maybe this is the best location for building the data center as well. Then the answer is that where is the best place for a data center, and how much renewable energy we should invest, how much storage we should invest, and when to generate, when to restore, and how we can just manage to not put the pressure and stress on the power grids and transmission line, to just make sure that we are not passing this pressure to our residential customer.
Great.
The question that I think most about is how can large-scale AI be made available to more people, right? If you have, just to give you some example of the kind of money that is involved here, right? So a typical data center has about 100,000 GPUs. Each GPU costs about $40,000. So we are talking about $4 billion in investments in GPUs, plus about a billion in other things that are required to run the data center. So that's a substantial investment.
Yeah.
How could this be made available to more folks? That's an important question to think about. And then how can something like this play well with energy infrastructure? So if a car costs $40,000, we are okay with keeping it aside, not having it run for a while. But if something costs $5 billion, it's very difficult economically to tell someone, hey, listen, this is going to be a peak hour. Why don't you shut your infrastructure down to operate it? I mean, if somebody shuts it down or throttles it down, they are playing with $400 million of investment, and they're struggling that investment. So the economics are very different here, and at a vastly large scale. So that's an important question for us to think about when we build AI solutions, because something at that scale may or may not be available outside this group of 3 or 4 5 major companies. How do we get more folks to participate? And I think reusing and replacement is the answer. That's what I look at more carefully, is how do we take the investments that have already been made and bring it to bear in scenarios where only smaller investments could be made to fine-tune the large models into the setting.
So you're certainly correct. There are many aspects of AI that are enormously expensive, and each of the private companies you refer to have access to hardware that in many cases is beyond that of most nation states. I mean, it's hard to overestimate how much computing power they have, and that we will never match as a university, and Entergy will never match as an individual company. So in keeping with the theme of this forum, which is that we're better when we're working together and bringing together folks from different kinds of homes and perspectives to come together, what's your wish for the future as Entergy and Tulane and other universities and other maybe public companies and others come together? How do you imagine us working together best? In some ways, what would Entergy like to see Tulane do? In order to provide, play our role in helping create the best future?
I think there could be a lot of ways. I think collaboration would be probably number one across from academia and from an industry perspective, where whether it's by understanding research that's happening, whether we're working together on projects, whether it's sponsoring a computer science team that we're doing. I saw Nick just walk in here, and we're already working together. We have a student team from the computer science. Yes, I see a team member. Hey, nice to meet you. So Tulane is currently working with us on an AI project right now to do something that we've not done before. So I think whether it's collaboration from being a thought partner, or whether it's collaborating based on actually doing real work and learning together, I think that's the first thing that comes to mind.
Yeah, great. And we'll have to keep our answers brief because we're getting close to the end, and we need to make sure there's time for audience questions.
Sure. I think As we know, and we talked today, that energy industry is just rapidly changing, and then data is getting more and more important for this sector as well. And I think from academic perspective, again, it's really important that we train our students with AI tools, data analytics, machine learning, to be prepared them to know more about the data, how to work with data, how to analyze the data. And then right now in Tulane, we have a Energy Institute that Pierre, he's doing great job, and then he's the director of our program. And then each year we're graduating great and outstanding students. And it's really important to help them to train and get more knowledge about the AI to be more competitive in the market. And then in this case, they can help the industry, and they can just connect us with the industry, and then we can collaborate together.
Great.
I will be very brief. I will just say, keep doing what was pointed out already. Students, industry, faculty, working together. That's where all the magic is going to happen. I think that's very, very important. Cooperative agreements are going to play a very significant role. Pooling resources are going to play a very significant role. That's one way in which a nonprofit can compete at the highest scale. And then getting access to national resources that might allow us to compete well as well.
So I have a quick question, and then we'll go to audience questions. And it's really just for me. It's a topic of interest to me. I've talked to Nick about it as well. And to my mind, the population is being divided into two groups. One group is happy to have AI tell us the answer without worrying too much about where the answer came from. And we have increasingly medical folks feeding an X-ray into a computer, and it says this lung is cancerous or not, without knowing what the computer is doing and how it's answering the question. I am on the side of human intelligence. I want to understand how the computer is reaching there. So I want to know, purely out of curiosity, how did the computer know that transformer was about to blow? Now that's probably on the simple side of the questions that will be being asked. But so where are each of you in the arena? Do you need to know, or you feel like you're going to get to a point where you're going to trust the computer to answer really important questions where the stakes are high and not worry too much about how it got the answer?
So I got two questions, right? I think I got two questions. One, you asked about the transformer. It's really just looking at voltage patterns that are coming from the meters from your house that are attached to your transformer. So that's what it's doing. I'm not really in the need to know camp. It's more of now. But there's also trust but verify, I guess, is also my view on it. And I'm very passionate about having humans in the loop of decision making when it comes to AI, especially now. So on one hand, it's very important for human judgment to be between whatever AI is telling you and ultimately a decision being made. That's critical. But knowing how it got there, I am not as concerned about.
Interesting. Eddie?
I think for me it's a different story. Maybe this is because I have been trained to be a researcher. When I'm just receiving any answer from even ChatGPT, I'm just going to the Google and writing the same question, just checking different papers, question and everything, and trying that what is the resource of this answer and how I get this answer, and then always trying to validate and the question, and then I think I'm using electricity more and more.
Yeah. Hridesh?
I think that if certain critical solutions need to survive and continue to benefit society, we will need to know. Because for those solutions, usually there will be some sort of a liability issue. And when there is a liability issue, lawyers get involved. And when lawyers get involved, if one cannot explain how that works, then those solutions get shut down. So I think that's at that point we will have to have an intersection between AI and law.
I will say, for those of us at Tulane, that's the most critical obstacle we're facing now. If we endorse an AI tool for any purpose, then we are responsible for its output. In which case, we better have reason to have confidence that its output is very likely to be accurate. Do we have questions from the audience?
Yes, the first question was asked by several people. Given
Okay.
the massive consumption of energy by AI systems, do you think it is a net positive or a net negative for total energy consumption?
Well, that's a topic we've kind of touched upon in various directions. Some of you are saying energy costs will go up, but not as much. Are the savings going to match the benefits the costs of this whole enterprise?
Well,
I think.
Well,
go ahead.
Oh my God, I'm the first one. I think the best answer is that for now, if we are talking about right now, the answer would be different maybe 3 years from now. I think right now maybe we are using more electricity than the before. If you're checking your bill and the consumption from the time, you're using more and more your laptops. I have friends and they're saying that sometimes when we feel bored, we are just talking to ChatGPT and then we are using more and more. And then I think the net is positive again, but I think we are using more electricity right now compared to 2 years ago. And then I think from my side, we are increasing our costs right now, but maybe next 2-3 years by changing the power market and the pricing mechanism, we can reduce it.
Any other quick comments?
I think it's an evolving scenario. That's
Very political.
As is usually the case with any evolving technology, it becomes more and more efficient with time, and that's what's happening. The technology that drives AI is becoming more and more efficient. I think we have to wait and see. And there is also the matter of global competition that cannot be ignored while making progress.
You want to add something? Or should I-
Ditto. Yeah, I agree.
Okay.
Yeah.
Next question from the audience.
This is a question specifically for Entergy. How is Entergy positioning itself to attract data centers to its service territory given their tech companies' requirements for low carbon solutions?
Well, I mean, we are, always, looking at, welcoming new development of any kind, whether it's a new AI data center or a large commercial industrial customer. And we've had some success so far. It's publicly announced we've got an AWS data center that's coming up in Mississippi. And so our point of view is that we do expect there to be more. But largely the data centers are the companies that have these data centers. They're doing a lot of the driving in terms of identifying. They have their own knowledge of energy systems and understanding what their needs are. And so a lot of it is driven by them to be able to find where they think the best place to site these data centers are. And then our job through our economic development groups is to accommodate helping them make that decision.
Great. Yeah. Another question.
What can AI do to improve the resilience of our energy supply during hurricanes?
So Andy, you've commented a bit about energy reliability. What about specifically in the context of extreme weather events?
Yeah, we're exploring a lot of ways. Obviously, we get hit by storms very frequently, and it's becoming more of a common event. We're always examining all dimensions of how we're responding to storms, including the supply chain questions. And it's being more predictive is the short answer. So storms out there brewing, predicting not only kind of when is it going to hit, where is it going to hit, what's going to get damaged, what resources are required proactively before we actually have the storm event. So just one example where we're using AI to get ahead of before the storm even comes and anticipate the needs of, from a supply chain perspective, what materials do we need? Where do they need to be staged? What people resources, crew resources, equipment resources need to be where and when, so that once the storm passes and it's safe to go out, we have people and assets as close to damage as possible so that the restoration can go as quickly as possible. That is an active project.
I would say, as a mathematician, people talk about weather prediction. I'm not sure that we will be predicting weather much more accurately or faster in the future. That's an incredibly difficult mathematical problem. So but maybe in 12 hours sooner or a day sooner may make a difference.
A few hours can make a
Yeah,
difference.
right.
Sure.
You know, I think that's all the time we have, unfortunately. It's been a really fascinating conversation. Please join me in thanking our panelists, and thank you all for joining us. I hope you have a wonderful rest of the Tulane Energy Forum. And yeah, thanks for being with us for a fascinating series of conversations. And thank you.
Thank you.
Thank you, Hridesh,
Thank you.
Praneem, and Andy.